Good evening. I'm Spot On Weather meteorologist Matthew Euler. And wow, do we have some interesting things to talk about tonight with the Teleconnections discussion for the 1st of January 2021. It's a Happy New Year, everybody. Happy New Year from Spot On Weather. This graphic here on the title slide tonight is a unique one. It's unique in the fact that this is a model that is showing, one of the models that's showing what's known as a stratospheric warming event. You can see the maroon and the orange shading there located over the North Pole area. And wherever you see that maroon shading, that indicates warming in the second layer of the atmosphere that's known as a stratosphere. And when this happens, interesting things really can happen. Well, first of all, the polar vortex tends to weaken or split apart. So this is a forecast coming up for by mid-January time frame of a stratospheric warming event. So this is something that is going to be really interesting in tonight's video to talk about. Looking at the starting with the MJO, the Madden-Julian oscillation phases and the areas of enhanced convection. Phases 1 through 8 again is what are generally utilized for the MJO to describe where the areas of enhanced convection are occurring. Whether that's phase 1, right there near Madagascar off the east coast of Africa, phases 2 and 3 in the Indian Ocean for the convection, phases 4, 5, 6 closer to the Australian area, and then phases 7 and 8 are closer to the international dateline, just around 180 degrees longitude. So let's move right into the forecast and let's see what kind of Pacific influences in the coming 10 to 14 days, what those are going to be. All right, so temperature composites for the months of January, February, and March. Those are on the left. Generally, if you like cold air in the eastern United States during the months of January, February, or March, you want a Madden-Julian oscillation in phases 8, 1, 2, or 3. If you like mild weather, you want an MJO in phases 4, 5, 6, and 7. So the graphic on the right shows the latest GFS ensemble forecast for the MJO. That green line generally represents the NCEP GEFS, Global Ensemble Forecasting System. The forecast out through the 15th of January. That green line there on the right-hand image. And that shows the MJO starting out in null phase, working its way towards a weaker phase 3 out through mid-January. The GFS operational MJO forecast, that's denoted by the aqua colored line, or you might see it as more of a lighter blue line. That's showing a null phase to start the period, and generally rotating into a little bit stronger phase 3. It goes out to phase 2, and then phase 3 with convection over the Indian Ocean. So those are the MJO forecasts out through mid-January. Moving ahead now to the La Nina update. With all winter forecasts, we must take a look at La Nina. This is a big influencer on the weather in the United States. And the graphic on the left shows the sea surface temperature departures from normal or anomalies in degrees Celsius. The blue shading generally indicates below normal water temperatures, whereas the orange shading or the maroon shading indicates above normal water temperatures. So we have La Nina there in the equatorial eastern Pacific continuing with the blue shading, below normal water temperatures, and then the graphic on the right shows the general blue line shows basically from early October to present, to the 1st of January, how the temperatures have fluctuated or changed, those temperature departures from normal in the Nino 3.4 region of the eastern Pacific Ocean. And our current values as of January 1st are sitting at minus 0.97 degrees Celsius. So if you want to round it up, you would say 1 degree Celsius water temperatures below normal in the equatorial East Pacific. But, last week we had a bit of a slight cooling, and now we've had a slight warming again. So the La Nina has now entered the weak stage. It's no longer a moderate La Nina technically. So now we're entering into the weak stage for La Nina. Now this is going to be interesting to see how this plays out over time. But I just want to give you the latest update. The waters in that Nino 3.4 region have slightly warmed since last week. And now the temperature departures are just slightly less than 1 degree Celsius below normal. Let's take a look now at the other teleconnections. We're going to start off with the Arctic Oscillation forecast. And with the Arctic Oscillation, generally a negative phase on the left and a positive phase on the right. Generally, the white line here on both graphics represents the jet stream axis, the polar front jet stream axis. And with a negative phase Arctic Oscillation on the left, you get higher pressure up over the higher latitudes, and you get lower pressure over the higher latitudes with a positive phase. It's kind of a reverse effect. So with a negative phase, you get a much greater amplification or a dip in the polar front jet stream into the Midwest and eastern United States. So that's where the coldest temperatures are going to occur, in the dip of that jet stream, where the jet stream takes that dive. Meanwhile, with a negative phase AO, you typically have a upper level ridge over into western Canada and off the west coast of the United States. The positive phase, on the other hand, you have more of a west to east zonal jet stream there on the graphic on the right with the positive phase. And so you don't get as much cold Arctic air coming down into the United States with a positive phase AO. So let's see what the forecasts are calling for the models here, for the forecast for the AO. Looking first with the European model, deterministic model. The blue line indicates, in these diagrams, indicates where the Arctic Oscillation was, and the white, like the white circular lines in each graph, represent the forecast from today, 1 January 2021. And this particular model goes out through about the 12th of January. And you see that this model, the white circle lines there, the latest model run of the European at 12Z today on the 1st of January, showing the Arctic Oscillation remaining fairly significantly negative over time. There's really no indication by the European model of the AO going close to neutral or even positive. The European EPS AO 50 perturb members, I want you to pay attention to the green line. That's the average or ensemble mean of all the members. Not even close. All the way out through the 16th of January, staying solidly negative, the AO. Looking at the European EPS AO 50 perturb members. Now this one usually has a bias towards a positive AO, a positive NAO. Has a bias towards warmer temperatures, actually, this model. Now, this is saying something when the European 50 perturb member EPS is still predicting, the green line there, predicting the AO to remain negative all the way out through around Valentine's Day. So in that case, we'd expect cold temperatures in that trough in the eastern U.S. through 14 February. Moving ahead to the GFS deterministic AO forecast, this now showing again the white circular line showing where the forecast is going. Now the GFS deterministic is showing a dip right on 7th, 8th, 9th January to less than almost -4 on the AO scale, and then it makes a climb slightly above positive there very briefly around the 15th and then back to negative again. So this one's a little bit less consistent, let's just say. And then the NCEP Jeffs V12 AO 30 perturb members, the green line again, ensemble mean or average, all the model members. Look at this. It's keeping it negative throughout, all the way through the 17th of January on the NCEP Jeffs V12. So, bottom line, AO is looking to remain negative. AO negative means colder temperatures in the eastern U.S. as well as a trough in the east and a ridge in the west. That's what that tells us. Now let's take a look and dissect the NAO. With the NAO, positive phase on the left, negative NAO phase on the right. Now this has been really impressive to watch in the models, especially over the last 7 to 10 days. With a positive phase, before I get to the models, positive phase of NAO, North Atlantic Oscillation, you have a west to east jet stream. That black line, black solid line, represents the axis of the polar front jet stream. So positive NAO phase, you have lower pressure in the vicinity of Iceland. You have higher pressure down around the Azores. Okay, there's no blocking with a positive NAO phase, and you have a west to east jet stream and relatively warmer temperatures over the mid-Atlantic and the eastern U.S. as a whole. The negative phase, on the other hand, of the NAO, you have a much different situation. You've got blocking into Greenland. Sometimes that blocking will orientate itself from the southeast or the northwest with the ridge axis all the way into Canada. All right, and that's generally what's showing up right now in the modeling. Generally, we get with a negative NAO phase, you get a cold trough. It could be actually multiple winter storms off the U.S. East Coast, off the Mid-Atlantic with a negative NAO phase. All right, so let's take a look at the forecast from the models. European deterministic, NAO. Look at this. This is what I call a tank. When the forecast goes all the way off the chart here around the 10th of January towards negative. So NAO, according to the European, is going to be negative through the 11th of January. That's indicative of that strong high latitude blocking situation. And in the models, we're looking at that from Greenland extending northwestward back to Canada. Now, the European EPS NAO 50 perturbed members, look at that green line, that's the ensemble average again, shows negative NAO through the 16th of January with the anomalous high latitude blocking from Greenland into Canada continuing. There's some models are indicating this may continue the negative NAO right on through late January, early February. Moving ahead now to European EPS North Atlantic Oscillation, 50 perturbed members. Look at the NAO here. It's negative all the way through Valentine's Day, through the 14th of February. Now, it does get closer to neutral a couple times between now and Valentine's Day, according to the latest run. Generally, 31 January through 3 February kind of gets closer to that zero line, neutral, and then it creeps negative again a little bit, and then kind of back towards neutral around the 14th of February. But look at this. I mean, this is a cold look. If you want winter weather in the eastern U.S., you like this. Now, the GFS deterministic NAO forecast, again, I've noticed GFS deterministic is a little less consistent as compared to the other models. It tends to waver a lot from one model run to the other, trying to figure things out. But generally, what you're looking at here, that white circle line there, again, is a major dip to negative NAO. Look at this. Look at how amplified that is. 7, 8, 9 January. That's a pretty significant NAO to negative. And then it comes up slightly positive again around the 12th of January. Right, negative NAO through 17 January. That's what NCEP JEPS V12, the GFS Ensemble Forecasting System, that's what it's telling us. Look at that green line remaining in negative territory below the zero neutral line. So no changes here. So let's talk about it now. We have a primarily dominant negative AO. We have a primarily dominant NAO, which is huge if you want winter weather in the East Coast. All right, now let's move into the PNA, Pacific North American forecast. Now, last week when I did this video, I recall, I updated the slides today, and I said, ooh, let's compare from last week's forecast to this week's forecast in the models, and what a difference. Now, I'm going to show you what I'm talking about. First, with PNA being positive, you typically get on the left, the bottom left there, we get increased chances with a positive PNA of below normal temps across the eastern U.S., okay? You get more of a western ridge, upper level ridge, or rising heights with a positive PNA in the western U.S. and the eastern trough. Now, with a negative PNA, it's the opposite. You get more of a trough. With a negative PNA, you get the trough in the western U.S., especially the Pacific Northwest, and you get the ridge in the east and the warmer temperatures in the eastern U.S. with a negative PNA. So what's it looking like? European deterministic PNA forecast. Neutral conditions generally for the first few days of January. But then look at the 4th of January to 12 January. Look at the rise in the PNA. That's indicative of that positive PNA, which you want if you want cold and snow in the eastern U.S. And it remains pretty much positive on the European deterministic out through 12 January. Now, this is, by the way, this is the European 12Z run for today, the midday run. The European EPS PNA 50 perturbed members, look at that green line, the ensemble average, showing again a rise in the PNA value. That's indicative of rising heights and upper level ridge building across the western U.S. Whenever things go up in the atmosphere, they've got to come down. Isaac Newton said it best, for every action there's an equal and opposite reaction. So you see the positive PNA values staying above the zero line with the European EPS 50 perturbed members showing, again, look at that climb. We have one climb between 4 January and about 6 January. Then we get another climb, positive 2, between 12 and 14 January. And then this model has it dipping down to negative territory beyond the 20th or 21 January generally. Looking at GFS deterministic PNA forecast, showing a rise, again, a climb in the PNA. Look at that, 5 to 15 January through mid-January. Look at that climb. Wow. And then transitioning to negative again there beyond the 15th and then back to neutral around the 17th of January. This is going to be interesting, folks. This is much different than last week's model forecast for the PNA, where it was indicating a somewhat of a negative tendency, which would put the trough in the western U.S. and more of a ridge in the east. So this is a big change from last week to this week. PNA, 30 perturbed members for the NCEP Jeffs, B12. Look at this. Positive PNA, 4 through 17 January. Wow. If you are a winter lover, if you really like winter weather in the east, this is really in mid-Atlantic. You really are enjoying these teleconnection forecasts right now. All right, moving on to the EPO, Eastern Pacific Oscillation Forecast. Now, I remember taking a look at the models, the last few days of December. It was not looking good if you wanted winter in the east. I'll be honest with you. I mean, it was looking mild. And then the Pacific jet stream was just really starting to roar and really increase its intensity. We had this huge Aleutian low that was sitting in the North Pacific, a series of just really intense low pressure systems. In fact, one just recently, just incredibly low pressure. I think it was about the 922 millibar low, hurricane force winds in the North Pacific and the Northeast Pacific. That's associated with a positive Eastern Pacific oscillation. We get these really strong low pressure systems in the Gulf of Alaska. And what that does, if you look at the graphic on the right, the purple arrows, that directs the jet stream to pretty much go west to east and really be strong across the Pacific. And then what happens is the North American continent with a positive EPO is generally flooded with mild temperatures. And so when I was looking at the models initially, last few days of December, just after Christmas, it was looking ugly if you wanted any kind of winter weather in the mid-Atlantic or the eastern U.S. It just was not looking good at all. But wow, have the models changed? Just in the past few days, I've noticed for Southeast Virginia, for example, a few days ago, it was looking like 50s and 60s the week of 4 to 8 January. Now, you're looking at 48 to 52 for a high. So it's changed a lot. That's one important thing about these models is, anything beyond 5 days, you kind of just take with a grain of salt because something's going to change. But anyway, what we really want, if you want winter weather and snowstorms in the Mid-Atlantic this time of year, you want the negative Eastern Pacific oscillation, where you get a upper level ridge building into the Gulf of Alaska, warm air over the Northeast Pacific and Alaska, building northward. That dislodges the cold air south. You get these Arctic highs to break off and generally move these baroclinic systems down to the southeast. With the graphic on the left there with the purple shading the cold in the Midwest to the East Coast. Oh, that's what you want. Highly amplified jet delivering the Arctic cold. So let's see what the forecast looks like. European deterministic EPO forecast. And I was looking at this and I thought, wow, the Pacific is going to start to really mess with us and dominate the pattern. If you like the mild weather, you really like this graph, right? A positive EPO from 1 through 10 January, but then it kind of comes back down closer to neutral after that. But look at how far up it went to the positive values. Even now, between the 2nd of January through about the 4th of January, it's pretty positive. It goes up to positive 4. And then it kind of comes down a little bit, then kind of levels off, still in the positive 3 plus, and then really drops down 7 January to about 9 January, really drops down closer to neutral. So I have, that Pacific jet was really intensifying out there. Look at the European EPO 50 perturbed member forecast. Again, all these are matching up fairly well. For the first week of January, we're looking at a fairly amplified positive EPO. And that's going to be indicative of those very deep, intense low pressure systems in the Gulf of Alaska. Look at the EPS, European EPS, 50 perturbed members. Now, this one, again, the first week of January, it really comes down, though, around the 10th of January. and then it remains kind of like around that, kind of straddles the zero line a little bit closer to more neutral conditions after 10 January. GFS deterministic EPO forecast, and you see the positive values again the first week of January. All these models are pretty much in line with a more active Pacific influence, with the deep low pressure systems delivering the milder air into the Pacific Northwest and into Western Canada. Another thing about the positive EPO I want to mention is you get these really strong, intense low pressure systems with their counterclockwise circulation. You're not only flooding North American continent with Pacific air, but you're also flooding Western Canada with Pacific air. And so even when you get frontal systems to come down from Canada, and even these like colder highs to come down from Canada, if you get a positive EPO and you got all that mild maritime air flooding into Western Canada, the air mass upstream is really not going to be that cold. I mean, it's going to be cold based on the latitude and the time of year, but it's not going to be nearly as powerful, the cold fronts and the cold surges behind those cold fronts with a positive EPO. All right, NCEP Jeff's V12 EPO, 30 perturbed members, and pay attention to the green line, the average ensemble mean, or ensemble average. Again, fairly positive EPO through 10 January. Then it comes down closer, especially the afternoon of the 9th of January. It gets closer to neutral and kind of tries to go back up again, but not nearly as amplified in the positive manner. Back to neutral again, 16 and 17 January. All right, now we have to talk about this polar vortex. You're going to be hearing a lot about it in the coming days for sure. If you were to Google polar vortex, the news agencies love the buzzword polar vortex. They really enjoy that word. It's gotten just as popular as El Nino, really. All right, the graphic on the left, that shows, now what I want you to pay attention to, let me just explain this briefly before I show you these forecasts and kind of explain these graphics. The blue shading represents the coldest temperatures in the stratosphere. You can see a scale on the right of each of these diagrams, and you'll notice the negative values. Now, when I'm talking about the stratosphere, we're going way, way, way high above the ground. So the higher you go in the atmosphere, the cooler the temperatures get. So the blue shading on both of these graphics shows where the temperatures are fairly cold, and that's what you typically would see. Now, last winter we had a strong polar vortex that set over the North Pole, and this air, because it stayed strong all winter, the coldest air, the blue shading there, remained over the North Pole where it normally resides. The yellow shading on these graphics represents warming stratospheric temperatures, okay? And so you're looking at the yellow, the lighter yellow shading, for example, is negative 40 to negative 45 degrees Celsius temperatures, right? And you're like, oh, that's still freezing. Negative 40, negative 45 Celsius. But normally you're looking at negative 75 to negative 80 Celsius temperatures up there in the stratosphere. So that's a significant warming, is what I'm getting at. The yellow shading represents warmer temperatures. Now, this is the GFS model for the polar vortex. I've been looking at the European, I've been looking at the global, the GFS ensemble forecasting system, the GEFS. I've looked at the Canadian, European. I mean, all of them are indicating that there's going to be a stratospheric warming event. And these occasionally occur in the wintertime, and what they do is they weaken the polar vortex. Sometimes you get it so, the polar vortex is weakened so significantly that you get what's known as a split in the vortex. And so the white circular lines here, that's important to look at too on this graphic, on these graphics. That represents geopotential heights. And when you have more circular white lines, that is indicative of a stronger polar vortex generally up on the North Pole. But when they get elongated, like the graphic on the left, how they're elongated, they're not quite circular anymore, they become asymmetrical. That indicates a significant weakening and stretching of the polar vortex. The graphic on the left is today, the 1st of January 2021. The graphic on the right, I go out in time to the last frame of the model run. That is the 17th of January 2021. Look at the difference between the graphics. Are you noticing this? The graphic on the left shows the polar vortex getting elongated and stretched, but it's still one piece. Okay? And the warming is at the top of the graphic on the left. You see the yellow shading? But over time, the warming comes in over the North Polar area, and what it does is it weakens the polar vortex to the point where it splits, into two separate circular vortices. And so the graphic on the right shows a polar vortex split. Now, this is tricky. It's tricky because, looking at research this past week, this is a tricky situation. Polar vortex, depending on where that split vortex sets up, is going to be very important in determining who gets the coldest air. Research, in fact, has shown that during splits, Europe tends to get the coldest air. All right, with displacements where the polar vortex is weakened significantly and has moved off the North Pole area, the coldest air with displacements is usually in the eastern United States. But I will again mention this, and I mentioned this in my social media this week. No two polar vortex splitting events and stratospheric warming events are ever the same. So generally, research indicates that either Eastern North America or Europe gets the brunt of the coldest air after the split, and it generally runs on the order of 2 to 4 weeks, a delayed cold air or change in the upper air pattern and a much more amplified dipping jet stream. So just keep that in mind. This is getting interesting now, though, because at least last year we had a strong polar vortex near record strength all winter. That thing couldn't be touched. And as a result, we had a very mild winter last year in the United States because all the coldest air remained bottled up over the Arctic. This year, we're showing signs of a split. The warming has already started. And so it's going to be interesting to see, who gets the coldest air. And again, it's dependent on where those lobes or the vortex sets up, where the coldest temperature set up. Okay, so what a great video tonight. We got to talk about a lot of cool dynamic stuff. Now, final thoughts. First of all, the Madden-Julian oscillation, the MJO, is in a null phase. It's transitioning to weak phase 3 over the next 2 weeks. Okay. Now, phase 3. Let's take a look. What does phase 3 represent? We look at the temperature composites once more. Look at that on the left. Phase 3 is pretty much cold from western U.S. to eastern U.S. So phase 3 is not very warm. Now, if it were to move into phase 4, now we have a competing factor, right? It could be warm. That would indicate warmer air moving into the eastern U.S. with a phase 4. If it moved into phase 5, even worse. If it moved into a phase 6, that's not nice for winter weather fans. It's extremely mild, way above normal in temperatures. So we want, hopefully, to keep this thing. If it goes to phase 3, it's not bad if you like the cold and the prospects of winter storms in the east. But if it goes into 4, 5, or 6, or even 7, that's a different story. But right now, it's only forecast from the null phase with minimal impact into a weak phase 3. So we're still not expecting significant activity from the MJO as of today's date, 1 January 2021. Something to keep an eye on. Pacific influence. Okay. Next, La Nina conditions. I keep saying this every week, and I really believe that a lot of the winter forecasts, including my own, was based on La Nina being a fairly strong moderate one, and it's not going that direction, okay? I think people are forecasting La Nina to be the dominant force for January and February here as we head into the real big-time cold months of the winter. But I just don't see it now. I've been following it closely, and we're at, like I said, just under 1 degree Celsius below normal water temps there in the eastern Pacific. So right now, based on that, I would say slightly above average temperatures are favored across the eastern U.S. just by virtue of La Nina. It'd be above average temps and drier conditions. But if this continues to weaken even further, we're already in a weak La Nina now. The weaker it gets, the less impact it's going to have on the overall atmospheric circulation patterns. I really believe that. And with La Nina, oh wow, I mean, it's amazing. And strong La Nina years are a lot different beasts than weak La Nina years, okay? Strong La Nina, the Pacific is in control. And they really live out to the general expectations a little bit more. Right now, with looking at the models, we have a very active southern branch of a jet stream, which is very typical El Nino, not La Nina. So there's a lot of factors. A lot of these teleconnections are fighting it out right now for dominance. Now, the Arctic Oscillation, it's forecast to remain negative. I mean, all the models are showing this out through mid-January. What does that mean? It, over time, is going to favor below average temperatures and a huge dip in the jet stream, upper level trough digging into the eastern U.S. from the Mississippi River to the East Coast. With the North Atlantic Oscillation, again, negative. And this is huge. We'd expect below average temperatures across the eastern U.S. with such a scenario, with anomalous high latitude blocking, that block continuing through middle January at least. And looking at the latest ensemble runs, model runs, wow, even the operational deterministic runs, you know, it's an anomalously amplified high latitude block from Greenland up into Canada. And whenever you get the ridging at the higher latitudes, you get the colder air dislodged beneath the ridging and generally below normal temperatures. So it's going to be really, really interesting. Eventually, you have to believe that negative NAO, the longer it stays negative, the more of an impact it's going to have on the overall pattern. The PNA, that's trending positive, and that is huge. Trending positive 5 to 15 January, that would lead to below normal temperatures across the eastern U.S. Again, so I got an MJO that's not very active, so minimal Pacific influence. Let's just review this real quick. I've got a La Nina that is weakening at less than 1 degree Celsius below normal water temps. I've got a negative AO, a negative NAO with a high latitude block on the Atlantic side. And then I've got a positive PNA. All of those are going to point towards colder than normal temperatures in the trough in the eastern U.S., all of them. And, you know, I talk about the difference between constructive interference versus destructive interference. Constructive interference is when the teleconnections work all together in the same direction with towards a similar outcome. Whereas destructive interference, you might have a one teleconnection. Let's just do this, for example. With a destructive interference, you have La Nina, let's say, that's strong. So that would indicate warm and dry conditions in the mid-Atlantic and the east. But let's say the NAO was negative. Okay, see how they're offsetting each other? That's a destructive interference situation. Now, the models are indicating a positive trend, the Eastern Pacific Oscillation, the EPO. And that's pretty much through about the 9th of January here as we start the new year. But that is going to transition to neutral. So initially, according to the positive EPO, we'd have a stronger Pacific jet. We'd have deeper or more intense Aleutian low pressure systems in the Gulf of Alaska, and you would have more of a maritime Pacific air mass flowing across the United States. And that would lead generally to above normal temps from west to east coast. But then that EPO again transitions to neutral after 9 January. So now that, if it goes neutral, that's basically like factored out of this equation for the forecast. Additionally, the models are indicating that splitting polar vortex with the stratospheric warming. Wow. This is a good one this year. This vortex and the strat warming is pretty significant, especially the time of year it's happening right here in early January. But in general, research has shown that there could be delayed results of that split polar vortex. Could be on the order of 2 to 4 weeks across the eastern U.S. And again, I have to stress, just because you have a split polar vortex does not mean that we're going to get super cold in the eastern U.S. And again, I always go back to 2019. I remember this vividly. Everybody was getting all pumped up and excited in the east about it being a colder and snowier time for weeks, and it got really frigidly cold, 40 to 60 below zero, wind chills up in the Midwest. Chicago looked some of the pictures there of the steam coming off Lake Michigan. It was crazy, the steam fog, and it just looked so frigid. And it was, but it only lasted a brief time, and then the polar vortex repositioned, the split polar vortex, one of the lobes. It repositioned itself to where it directed the coldest air into the western U.S., and we were mild the rest of the winter. It was frigid up in Montana. It was frigid up in the Dakotas. It was frigid up in the Pacific Northwest in February of 2019 because of the polar vortex, but not here, not in the east, not in the mid-Atlantic. So just because it's happened before in the past. There's always a slight probability it won't happen necessarily that way. Now, on the other hand, if the vortex, when the split vortex sets up over eastern Canada and directs the cold pretty much on its backside down to the eastern U.S., that could be a real interesting situation. It could be very, very cold mid-January to mid-February time period. So that's very much on the table tonight. All right, so overall assessment. I mentioned this already about the positive EPO. I think it's been a big factor right now in keeping the temperatures from really dropping off in the eastern U.S. With the strong negative NAO and AO, that generally leads to very cold winters in the east, but the influence of the Pacific has temporarily offset that. And I think the strength of the EPO being positive really has played a big role in that, in keeping temperatures in check from getting too cold here. In fact, we've seen some mild surges, from the Christmas Eve storm, where we got that huge south to north wind all the way up into eastern Canada from the Caribbean. That was quite a system there, and what an anomalous pattern that was before that cold front blew through and really dropped temps. The La Nina, it continues to weaken. I keep seeing these graphics about how things are going to be above normal, but if it's based off La Nina, I'm not sure why, because it's weakening right now. Additionally, will the MJO, now this is a golden question, will the MJO come to life in warmer phases? Will it become more amplified in the coming weeks? That's something that's going to have to be watched, because the EPO may be going back towards neutral around the 9th of January, but you got to watch the MJO. That's an important one in the Pacific. La Nina looks to be, with its weakening, less and less a factor in the overall pattern, atmospheric circulation pattern, but the MJO can really put a damper on your winter weather hopes in the east. It's really done a number on our pattern the last couple winters, the very mild winters we've had. Now, the impressive high latitude blocking, model run to model run, is just consistently there. And that's going to stretch from Greenland, and eventually that ridge, the ridge axis, the upper level ridge, is going to orientate itself into Canada. You got this huge dome of warm air at the higher latitudes where it does not belong. You're going to have colder air underneath that with a negative NAO, and that could have a huge bearing on the upcoming weather as far as temperatures go, as well as the storm track. And the PNA. The PNA is trending positive, and that wasn't even a thought a week ago when I did the video. And with the Pacific North American pattern trending positive, you get the upper level ridge, the rising heights out in the western U.S., and what goes up must come down. So east of the Rockies, you get more of a dip in the jet stream, and the colder air comes down the front side of that huge upper ridge. So PNA is trending positive. Polar vortex, again, could be a huge player from mid-January to mid-February, dependent on how the vortex splits into its pieces. Does the coldest air get filtered into Europe? Or does a piece of that vortex come down to eastern Canada and really get us with some winter weather? That's what's going to be remain to be seen. It's a little bit too early still to tell that. All right, so for right now, off the night's video, I've got 2 teleconnections indicating above average temps. I've got 4 now that are indicating below average temps. So let's look at the 2 above. The 2 above, again, were the weak La Nina as well as the positive EPO. Those are my 2 teleconnections indicating above average temps. The 4 below average, wow, it's starting to really line up well. We get, a negative AO, 1. Negative NAO, 2. All right, we get a polar vortex split with the possibility of below normal temps, 3. We get a positive PNA, 4. So again, this is going to be interesting. So overall, based on the assessment, based on what I'm looking at today, it's going to change, models change, but as of right now, 1 January 2021, I think the teleconnections definitely favor below normal temperatures in the eastern U.S. and the mid-Atlantic, overall between today, 1 January, and the middle of January, 15 January. And I think if you like winter weather, if you like cold temperatures and possibility of winter storms in the mid-Atlantic, things are really looking up. They're really looking good right now. Now, the atmosphere's got to cooperate. We can look at the charts all day long, and you can see, the high latitude blocking, negative NAO. You get a positive PNA. You get a inactive MJO, you get the EPO at a neutral or even a negative state's even better. Polar vortex, everything can line up beautifully, but the atmosphere still has to cooperate, right? So that's all I got tonight in the video. I thank you for subscribing to this YouTube channel, the Spot on Weather YouTube channel. I really enjoy sharing this. I have a passion. Teleconnections and seasonal forecasting I just love. And so hopefully all my work and what I've been looking at and the models and explaining in this video kind of makes sense to you. I try to break it down in more simplistic terms for everyone to understand. But Happy New Year, everybody. I really wish you the best in 2021, especially with good health. Stay healthy out there. Do your best to keep that social distancing going. And I really hope everybody's health. Wish you the best of health in the coming year. All right. And nothing but prosperity in 2021. Thank you again for subscribing to Spot on Weather. That's all I got tonight. And if things get more interesting with any particular events for winter storms, I'll probably make a special video. I've actually kicked around maybe doing a polar vortex special video at some point, just again show everybody what it's about, because I think that one's going to be, it's the wild card in the pattern, but it's also one of the more significant ones this winter that we definitely did not see last winter. All right, take care, everybody. Have a great night. God bless.